we'll have a break after this. Or we'll finish up after this. So if you... Yeah, please, remind me that. There's no... Yeah, I turn it off because you don't want big gaps in it or whatever. Okay, here we go. So if you look at this example here, we split this. So it's pi over 8 to 0. We split it to sine squared 4x times sine x, sine of 4x times dx. So try to do that up a bit. I'm going to zoom this up a bit as well so we can see it properly. I'm going to rewrite that. I'm writing too big here. So pi over 8 to 0 of the sine squared 4x times the sine of 4x dx. Step number 1 is split the cube into a square and a single power. Step number 2, we substitute in 1 minus cosine squared 4x for sine squared 4x. And then we have sine 4x dx. Step number 3, we multiply it out. So that's sine 4x minus sine 4x, bracket around these, so dx applies to both of them, times 4x. I'll just drop the bracket on the 4x, don't need it there. Then we go from pi over 8 sine 4x dx minus the integral from pi over 8 to 0 of the sine x cosine squared 4x dx. And that gives us, obviously, we identify this one, we say sine x, cosine x, sine 4x. I'm sorry, I made a mistake there up above. If you give me a second, I'll correct that mistake. 4x dx. Obviously, in here, I should have 4x, not just x. 4x in there, and that's of the type integral of, so this one here, this trigonometrical product is of the type a times f prime x times f at x to the power of n dx. So it's saying that it looks like we have a product of two functions, trigonometric functions, the sine and the cos. One of them is brought to a power. It looks like the one with that it doesn't have a power is the first derivative or a multiple of the first derivative of the other one. And if that's the case, it means we can apply this rule, n plus 1 over n plus 1. We can apply the standard substitution rule. So if we come and test this, we say let f at x equal to cosine of x, cosine of 4x. G at x is the other function, which is the sine of 4x. The first derivative of f at x is sine of 4x divided by 4. And then we work out our a, where the a is, we have a sine of 4x in both terms, the g of x and the g at x and the f prime x. So we can say that a is equal to the 1, which is the coefficient of sine 4x and g at x, divided by 1 over 4. Because remember, the coefficient of sine 4x is a quarter. It's divided by 1 over 4. So a is equal to the inverse of 1 over 4, which is 4. Then we ask ourselves the question, is a times f prime x equal to g at x? If it is, we can use our rule. So let's multiply this out. A is 4 times sine 4x over 4. That is equal to sine of x, sine of 4x. That is equal to the sine of 4x, which is equal to g at x. Therefore, the answer is yes. So we can use our rule. And if I go ahead and use the rule then, that says the integral of sine 4x cosine squared 4x dx is equal to a, which is 4. sorry, I should have had the a up here and the rule above. A is 4, cosine 4x is our function f at x, and the power was 2, so now it's 3, and we divide by the 3. So we have worked out our integral there of that function, so we can now substitute it in up above. So if I come back up here to here, I'm integrating these ones. So the integral of sine 4x is equal to minus cosine of 4x over 4, and that's going from the limit pi over 8, use green for that, pi over 8 to 0, and this is minus, and in here we have 4/3, 4 times the cosine of 4x cubed over 3, and we're going from the upper limit pi over 8 down to 0. Clarify something here. F at x is cosine 4x, therefore the first derivative is minus sine x over 4. So in fact that gives us here a is minus 1/4 and a is minus 4. So if I just put in the minus here, that gives us the correct answer there. So apologies, thanks for pointing that out there. So the derivative of f at x cosine 4x is minus sine 4x divided by 4. So our coefficient there is minus 1/4. So I'm dividing here by, when I'm working out a, it's 1 divided by minus 1/4, which gives me minus 4 for a. So that all the way down here, that gives me minus 4, and here is the answer, and minus 4 in there. So then if we come down here and continue on with this, this gives me, let's work out what our limits are. So before we do it, it's handy to actually plug in our upper and lower limits into the cosine function. So it's minus pi over 8, and that gives me cosine of pi over 2, and if we remember from before, that implies that that is equal to 0, and if we do cosine 4 times 0 as our lower limit, that's the cosine of 0, which is equal to 1. So similar to the last example, so we then plug our values in here. So this is minus the cosine, the upper limit we said was pi over 2 over 4 minus, and then I have the lower limit, which is cosine 0 over 4. So I put in the upper and lower limits there. That's the pi over 8 limit, that's the 0 limit, and then we do the other function. So it's minus 4 times cosine of 0 cubed, minus 4 times, oh sorry, not 0, pi over 2 cubed, minus, and it's minus 4/3 cosine. I didn't give myself enough room here to do this, so I'm going to go on and do it on the next line. I'll just write smaller, write out again, but I'll write smaller. So this one is minus 4/3 cosine of pi over 2 cubed, minus, and it's minus 4/3 cosine 0 cubed. So I've done my upper and lower limits in both cases. That's pi over 8 substituted in, that's a 0. And this gives me minus 0, because cosine of pi over 2 is 0, minus times minus 1 over 4, the cosine of 0 is 1, minus, and here we have minus 4/3, this one, sorry, I should say goes to 0, because cosine of pi over 2 is 0, so it's 0 minus, and this one is minus 4/3, because the cosine of 0 is 1. So this gives me plus 1/4, minus times, and it's, we have minus times a minus gives me a plus, but then we have another minus, which means it's minus 4/3. And that gives me, the lowest common multiple is 12. 4 goes into 12 3 times, so it's 3/12, and here 3 goes into 12 4 times, so it's 16 over 12. So that gives me minus 13 over 12. And I'll just double check that for any errors. I think that's correct.